Hello dear students, welcome to the part 2 of vertical circular motion. Whoever is watching this video for the first time, I would request you guys please watch the video which was the part 1 of the vertical circular motion. Then it will be easier for you to understand the part 2. Okay, so proceeding further, let me consider a body which is performing vertical circular motion like this. So I am drawing this vertical circular motion in terms of dotted lines. Okay, so this is vertical circular motion. Let me say this is the string with the help of which vertical circular motion is going to happen. This is center. At topmost point, let me say the velocity at topmost point is Vt. The tension along the string at topmost point will be T. T stands for tension, and then mg acting downward. Okay, so this is the scenario at topmost position. Now speaking about bottommost position, the velocity, let us name the velocity as Vb. Let us say the tension is acting along the string Tb, and mg, which is always vertically downward, let us call it as mg. Okay, now this is center O, this is bottom point B. Now here we are going to find what can be the difference in tension at top, that is Tt minus Tb. This is what we are going to find in this lecture. Okay, so before starting with the derivation, I would like to revise the expression which we have derived in our previous video, that is the part 1 of vertical circular motion. I had derived this expression, that is Tt, tension at topmost position, is equal to mvt square by r minus mg. This was an equation which was derived in the previous video. The next equation which we had derived was tension at bottommost point, that is mvp square upon r plus mg. This was the second equation which we had derived. And apart from these two equations, we had derived one more equation, that was that is velocity at bottom is greater than velocity at top, that is Vb will be equal to Vt square plus 4rg. This expression was derived in our previous video. Let me call this equation as equation number 3. Now, since we intend to find the difference in tension, let us start by subtracting equation number 2 with equation number 1. Now, if you guys are wondering why 2 minus 1, why not 1 minus 2, it's simple, it's very simple. You can clearly see from the expression that equation number 2, that is tension at bottommost point, is much greater than tension at topmost point. Even logically you can think that whenever the body will be reaching the bottommost point, the tension will be greater at that moment. Anyway, dividing equation 2 minus 1, LHS will look like this. Tb minus Tt will be equal to RHS. First I'll do one thing, I'll take m upon r common from these two terms. I'll be left with Vb square minus Vt square. Then the other two terms I am subtracting, plus mg, I am subtracting with minus mg, so minus of minus mg. I've got two expressions now. Now again, continuing, m upon r is equal to Vb square minus Vt square will be equal to 2 times, oh sorry, this is not equal to, this is plus 2 times mg. Now, from this expression, we can easily figure it out that Vb square minus Vt square is equal to 4rg. Substituting 4rg over here, I'll be getting m upon r multiplied by 4rg plus 2mg. R gets cancelled. That'll give me 4mg plus 2mg. In all, I'll be getting 6mg. So in this lecture, we have, in this tutorial or in this video, we have derived that tension at bottommost point and topmost point will be having a common difference of 6 mg. Please note that this is a general expression. That means this difference in tension is applicable for any condition if the circular motion is a vertical circular motion. Thank you. Have a nice time. Bye-bye.